Okay, so here is the question. This is the most famous question on LeetCode. And the question says that given an array of integers nums, an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So we have some example here. For the first one, for example 1, we can see that our target is 9 and here is the array nums, and since summation of 2 and 7 is 9, we should return the indices 0 and 1. And then for our next example, we can see that summation of 2 and 4 is 6, and we should return 1 and 2 since index of 2 is 1 and index of 4 is 2. So okay, since the question says that we have exactly one solution, it seems that we don't have any edge cases here to check or if our nums is empty or etc. And for this scenario, let's bring a better example here, since the example that the LeetCode provides is not a very good example for our case. Consider a scenario like this one, 6 and minus 6, and our target is minus 2. Okay, so in this example we can see that and the output should be 1 and 3, since summation of 4 and minus 6 is 3. So to solve every question in the interview, it's good to bring the brute force approach at first. So, and for your when you are doing LeetCode or any type of the codes, I think that it's better to implement the brute force approach at first, and then with improving the brute force approach you can reach to the optimal solution. If you know the optimal solution at the first glance, okay, you can go with that and solve that. But I think that in the interview it's a good idea to bring the brute force approach, and then if you know the optimal approach, implement the optimal approach. And so here we assume that we don't know anything about the optimal approach, and we want to solve this question with the brute force approach at first. So the brute force approach is we can select each number and search in the other number that we have, and then calculate the summation of the numbers, and if we reach to the target we break our operation and return the result. Okay, so I mean, let's start with number 1. We start with 1, we go to the other number that we have. Okay, so I use one loop here to go to select each number. I select I as index, I is 0, and the first number is 1. Okay, so this is index, this is the first number. Okay, and second number. Okay, so if the first number is 1, then what's happened? We can select 4, 6, minus 6 as the second number. 4, we check that 1 plus 4 is minus 2. No, we go to the next one. This is 6. We check that, not true. And finally we check minus 6. it's not true. Okay, so we cannot find any number to add to 1 to reach to the target, that is -2. Okay, and also index of this, the second number is in, let me to write this, index of first number and first number, index of second number and second number. Okay, so index of the second number is j, and then we check the different number here. So then we check, okay, I is 1. What happened here? The first number is 4. Okay, and then the index of the second number is started from this one, since we already checked the combination of 1 and 4, and we cannot use 4 plus 4. So here we say, okay, j started from here and go to the next values that we have. Okay, so a start of it's a start from 2, and second number is, we have that here is at the first step is 6. 4 plus 6 is -2 now, and then we change this to -6, and we can see that this plus this one is -2, and also this j changed to 3. Okay, so overall we use a 2 for loop or 2 nested loop and go through the array, and in every index we check that the summation of the two number, and if their value equal to target, we return the indices of the two loop that we have. Okay, so okay, as I said, we start from 0 until the last value. Here first number is this value as we discussed, and then we go through I plus 1, the next value at the index I, until the last value, and here the second number is nums of j. Okay, at each step we calculate the summation of the two number. Okay, two number summation, which is first number, second number, and we check this two number summation. If these two are equal to each other, we can return, and what we should return? We should return the index of these two numbers that are I and j. Okay, so that's it. That's the first solution for this problem. Since we know that the question has exactly one answer, we don't need to check any other edge cases, but definitely you should consider this edge case if they didn't provide any hint related to the answer in our question. For example, maybe someone asked that, okay, if you don't have any answer, you should return an empty list. So if we have same scenario, we should return something here, since we check all of the indices and we cannot find any two number, and by end of that we return this value. Okay, so let's to run to see that right it worked for this scenario. What is the time and the space complexity here? Time complexity, space complexity is for time complexity, we go from 0 until the end of this array, and we, for each index in the first loop, we have to go again from the next index until the last value in our array. So we have a nested loop, and is O of n2, which n is the number of them, which n is the len of the nums. And the space complexity, since we don't save anything we don't save anything here, we only have first number and second number here, and I put this here to be more clear. We can only use nums I here and nums j here, and since we don't have any extra space here, the space complexity is O of 1, since we don't have anything to save. Okay, so this is the brute force approach for our problem. What is the optimal solution here? Okay, so this is a very good question. What is the optimal solution here? If the interviewee asks you what is the optimal solution here, okay, so the answer for this question is that from which aspect we want to optimize the solution. Maybe they ask you to reduce the time complexity, or maybe they ask, we want the best space complexity, and we don't care about time complexity, time at all. Okay, so if they say, if they bring this concern, we already have that. But if we want to reduce the time complexity, we should provide another solution here, since probably we can reach to a solution with O of n, since we can save some data in a data structure and then use that data structure to save to reach to the target. But do we have okay, so do we have any idea how we can save those data? So I think that the most famous data structure is hashmap or dictionary in Python, and we can use that. So what is the intuition behind that? Is that okay? So let me to go down here. Okay, so we can define a data structure as hashmap here. Okay, and analyze the question with this way. Same as before, we use a for loop to go through this array. At the first step, we select 1. Okay, and then if we reach a number, so at the first step we have number 1 or first number to 1. So if we add a number to 1 to reach the target, okay, we have x plus 1 equal to target to -2. Okay, what is that number? X is -3. Okay, so then we search in our array to see that, okay, do we have any -3 in our array? No. We say that, okay, let's go to check the other numbers. Again, we go to first number as 4, and we check that, okay, x plus 4 equal to -2. So what is the x? X is -6. Okay, so we can return here, but the problem is that when we are checking this number, we don't have anything in our hash map. Okay, so at the first step we say, okay, we go with 1. We don't have any -3, since at the first step our dictionary is empty. But okay, so say that, okay, here is the or hash map. This is the initial phase of the solution, and then we go to first number, that is 1. Do we have any -3 in our hash map? No. So we say that, okay, hash map is, we have 1, we add 1 to the hash map. Okay, so when we add the 1 to hash map, what we should add here, we don't know yet. Okay, so let's to add nothing there for this step. And again, here we have 1 and 4. Okay, so again we go to the next number, that is 6, and this is -8, and this is 6, this number, and then we go to -6 and -6, and this is 4. Do we have 4 in our hash map? Yes, we have 4. So we have 4. What we should return here? We should return the indices of these two numbers. So how we can reach to those indices? We can use that array, or we can use that hash map. Definitely we can use that hash map. So since going to this array to find the index of 4 takes O of n time again, but with this hash map, searching with hash map, searching for a number is O of 1 in the best scenario. It has some problem, but let's assume that is O of 1 here. So this is, if we save the indices of the number here. Okay, so if we save the indices of the number here, we can definitely reach to our to number very fast. Okay, so the way that we want to solve this is so clear now, and we can go with the coding. Okay, so I define a hash map that map the value to index. We go to the array okay, so and in each step here we can say that, okay, the number we are looking, okay, so we are looking, or we only say that some other name here is is the target minus, let me to say that first number here is the first number. Okay, so we select 1 here, and then we search for -3. We select 4, we search for -6, we select 6, we search for -8, we select -6, we search for 4. Okay, and this is a way in Python that we can use the index and the value at the same time. Okay, so we can say if the value that we are looking in map value index, if we found that number in the hash map, we can return here and say, okay, what we should return here? Definitely we can return I, since the order of the output is not important at all, and the index of the value that we are looking. So we have this value and we can return that index. Okay, and if we don't have that value in our hash map, we should add that value there. So we should say, okay, map value index of the number that we are working on is index of I. Okay, so if you go through this, you can see that first number is 1, okay, and its index is 0. Do we have -3 in our hash map? No. So add that number to the hash map. The key is the value, and the value in the hash map is the index. Okay, so here this is the second solution that we have. So let's me to run it to see, do we have any error in that? No, we don't have, and it seems that it works. What is the time and space complexity for this solution? So the time and space complexity, since we only have one loop here through the array, we can see that it's O of n. We have one loop here and we have one search in the dictionary here. This is O of n. This is O of 1. Okay, so it can be sometimes O of 1 is the best search engine. In the dictionary we have some problem with this, so we can cover this issue in the next videos. And space complexity, since we have a dictionary here and we have saved our data in the dictionary, so the space complexity is O of n. Don't forget to say this for in the interview. Time complexity and the space complexity is O of n, which n, what is the n? N is the length of the array that we are working. Okay, so let's to submit this one to see that it can work for all of the test cases. Yeah, it's work here. So okay, perfect. So let's assume that we have one follow-up question from the interviewee. Follow-up question. Assume that we are out of space and we are out of space and we want the values of the two number as output, not the indices, and we want a solution with time complexity less than O of n2. What is your approach? Okay, so what would you do in this scenario? I think that you can put your solution or your idea in the comment section, and let's finish this question here. Thank you so much.